In this video, I want to discuss a neat application of suffix arrays and LCP arrays, and that is finding and counting unique substrings. There are a variety of interesting problems in computer science, especially bioinformatics, that require you to find all the unique substrings of a string. The naive algorithm has a terrible time complexity of n squared, which requires a lot of space. The idea is to generate all the substrings of the string and dump them inside a set. A superior approach is to use the information stored inside the LCP array. This provides not only a quick, but also a space-efficient solution. I'm not saying that this is the canonical way of finding all unique substrings, because there exist other notable algorithms such as Rabin-Karp in combination with Bloom filters. Let's now look at an example of how to find unique substrings. Let's now look at an example of how to find all the unique substrings of the string AZAZA. For every string, there are exactly n times n plus 1 over 2 substrings. The proof of this I will leave as an exercise to the listener, but it's really not that hard to derive. Now notice that all the substrings here, there are a few duplicate ones. I have highlighted the repeated substrings. There are exactly 6 of them and 9 unique ones. Now let's use the information inside the LCP array to figure out which of those substrings really were the duplicate ones. In the table on the right, I generated the LCP array for the string AZAZA. Remember what the LCP array represents. It represents that two adjacent suffixes of the original string share a certain amount of characters with each other. So, if the LCP value at a certain index is, say, 5, then there are 5 characters in common between those two suffixes. In other words, there are 5 repeated substrings between those two suffixes, since they come from the same larger string. So if we inspect the first LCP position at index 1, we see that it has a value of 1. We know that the repeated string is the first character, being A, so we know that A is a repeated substring. The next LCP value is 3, so there are 3 repeated substrings between AZA and AZAZA, namely A, AZ, and AZA. The next interesting LCP value is 2 for the last 2 suffixes, so there are 2 repeated substrings here we can eliminate, Z and ZA. We can then come up with an interesting way of counting all unique substrings. We know how many substrings there are, and that is n times n plus 1 over 2, and we also know the number of duplicate strings, that is the sum of all the LCP values. If this doesn't make immediate sense, try out a few examples and play around with it. If we go back to the example we just did with the string AZAZA and we set n equal to 5, which is the length of the string, then we can get the correct answer of 9 by punching n equals 5 and then removing all the repeated substring values summed up in the LCP array. Alright, so if you're looking for a programming challenge concerning counting substrings, like I mentioned here, check out the link to the Kattis online judge for some practice. I also included some source code for the suffix array and LCP array available on GitHub at github.com/williamfizet/data-structures. Thank you for watching, and in the next video we'll be talking about other applications of suffix arrays and LCP arrays. Stay tuned.